This is the first video for the 4.2e lesson, Graphing Systems of Linear Inequalities. Number 1 says, Josh says that the intersection point of the boundary lines is always a solution of a system of inequalities. Beth says the point of intersection may not be part of the solution set. Explain who is correct and give an example. All right, so in this lesson, we're going to be looking at a system, 2 lines, and we're going to be doing the shading in solid or dashed. And we're going to build an example, and this one's going to be y is greater than or equal to x plus 2 will be our first line, and our other line will be y is less than negative x plus 2. Okay, so does the point of intersection need to be included as part of the solution set? Let's see. We'll start with our red line, or excuse me, blue line, either one, I suppose. And we're going to put a point or y-intercept into a slope of 1. And this one is solid. And this one would be shaded, y is greater than or equal to, would be shaded above. We're going to wait to shade until we look at our other line, but you can start to sort of visualize where that is. This one starts at 2 and it has a negative 1 slope. And this one's going to be dashed. And shaded below. All right, when we look at shading these, you're welcome to do some partial shading. This one was above, and this one is below. And then somehow darken the overlap. Alternatively, if you look at it and you feel like you can identify it by just thinking about it, we can just mark the final shaded region, also known as the feasible region. We'll see that word show up in this lesson as well, feasible region. All right, so the point of intersection for this was at 0, 2. And so we're going to see, is it part of the solution set? So if we take the line or linear inequality, y is greater than or equal to x plus 2, and plug in this point. Does check out. And now we'll check it in the other one. And we see that actually the point of intersection does not test out for the for the dashed or dotted line. And it needs to work for both. So in fact, the solution set for this is everything in the feasible region, but not this point of intersection. We can pick things on this solid line if we want to, on this portion of it, stopping here. We can't pick things on this boundary line because it's dashed. And so it says, Beth says the point of intersection may not be part of the solution set, and Josh said that it always was. So we'll say that Beth is correct. And Josh was incorrect. All right. Now we could change this in this system. We can include a little equal sign underneath, and then it actually would work out. But Beth would still be correct because it's best to say that it isn't always part of the solution set. It's just going to be based on what our system of linear inequalities is. Number 2, explain in words when a system of linear inequalities might have no solution. All right, so we're going to do the same thing. We're going to set up no solution. We often saw this with parallel lines. So let's make up a set of parallel. We'll do y is greater than or equal to x. And it will be solid. All right. My line's off just a tad. Please excuse that. And then my other line I'm going to use for this one is y is less than or equal to x minus 5. This one's also solid. And although my graph does not look parallel, we know mathematically these are parallel. And the black line was shaded above, so we could start to visualize that. The blue line was shaded below, and we're looking for the overlap of the shading. So we're not going to shade anything on this. And in fact, this is no solution because there is no common shaded region or feasible region. So we'll put something like, if there are parallel lines shaded in opposite directions, then we have no solution. But not all the time, because it is possible that we could shade the black one below and the blue one above, and we would have actually a feasible region. It just so happens these are shaded in opposite directions and they never touch or overlap. All right, and now we actually get to some problems where we will practice this. It says graph the system of linear inequalities, label the boundary lines, and determine if the point of intersection is a solution. Shade the feasible region of solutions. All right, so if an equation is not in slope-intercept form, that seems to be our go-to, especially for linear inequalities. And we're going to do this as a dashed or dotted. You can do some light partial shading and then darken the final one, or you can wait and just do the final overlap. The other one starts at -3 and goes up by 1 and is solid. All right, so the blue one was below, which would be here, and the red one was above, which means that the overlap is in here. And there is my feasible region, which is said to shade. Again, if you like to sort of lightly mark where the blue one might be, you go like this, and the red one or the other one was like this. And that might help you see why we shaded that portion that's to the left. All right. The other question it asks is the point of intersection a solution? And since one of them is dashed, we'll put no. So we almost know, in fact, we do know right at the start, unless the lines happen to be parallel. So number 4, because if the lines are parallel, even if they're both solid, there isn't going to be a point of intersection. All right, this first one I'm going to do in black. Has a -2 slope. And it is dashed. And the other line, we need to do a little bit of work to isolate y. which includes flipping the inequality sign. This one is solid. And speaking of parallel lines, here we go. We got some parallel lines. And let's see, this actually could have shading, but let's see. So the black one is shaded below and the blue one is shaded above. So that's bad. So this actually has no common feasible region. We'll put no solution. We'll keep the rest of our graph there. We're not going to shade anything. I would not do the partial shading on this one to be certain that you are indicating that there is not any feasible region. And the answer to this is no as well, because the lines don't even cross. And even if they did, one of them was dashed.